if 0 is less than x squared and x squared is less than y, which of the following statements must be true? We have following 1, 2, and 3 statements. Each of them is an inequality with variables x and y. The fact that the question points out to determine the statements that must be true means that we are trying to check which of these affirmations or statements is valid in all cases that coincide with this background premise. This is our assumption here. We're assuming that these conditions reflected in this double inequality is true. So, provided that the above is true, we need to determine whether the statements are always true or not. Let's try the first one. What do we see here? X is less than y over x. One way to try to make sense of this inequality to see whether it is always true or not is to simplify it in terms of putting together the two variables x on both sides of the inequality. We would achieve that by multiplying both sides by x, so that this would result. On the left side, we would have x squared, right? We would multiply x by x and also y over x times x. We would remove, right, x on the right side, and it would appear as x squared on the left side of the inequality. Okay, that's in general what we are expecting, but be careful. We need to consider two cases. Why? Because the fact that x squared is greater than 0 means that x might be positive or negative. So we need to consider what happens if x is positive and I do that operation of multiplying both sides by x. Let's see. X times x on the left side is x squared. Y over x times x becomes y. Since x is positive, I've multiplied both sides of the original inequality by a positive number. The direction of the inequality symbol would remain the same. So, actually remains the same because we're considering the first case where x is positive. Okay, what happens about this inequality? It means that when x is positive, the inequality number 1 is actually transformed into one of the inequalities in our premise, this. And therefore, it must be true because it coincides with something that we already assume as true. Okay? What about the other case? We have another possibility when you multiply by x both sides of the first inequality. The fact that x can be negative. If x is negative, we multiply by x on the left side, we multiply by x on the right side, and we get the same thing, exactly the same thing. What is it? It is x squared and y. But the inequality symbol in this opportunity will be inverted like this. So we obtain an inequality that directly contradicts our premise, our assumption above. If x squared is less than y, then saying that x squared is greater than y must be false. So we have that inequality number 1 can be true or can be false. So it's not always true, depending on the sign of x. Let's analyze number 2, option 2, or statement 2. It says that x cubed is less than x squared times y. One way to try and simplify would be dividing the original inequality, right, by x squared. Provided that x squared represents always a positive value, okay, we will have this. By simplifying, we have the inequality x is less than y. Okay, now we need to assess whether x is less than y is always true whenever x squared is less than y. What would I need to know that would guarantee that x has to be less than y? If besides knowing that x squared is less than y, I were given an extra condition. For example, this extra condition that x is always less than or equal to x squared, then this would guarantee that x has to be less than y. Because if x is less than x squared and x squared, this one here is less than y, then by transitivity, you would have to say this. So in order to guarantee that x is less than y, I would need to examine this postulate. Is this condition true? Can I assume that the fact that x is a positive or negative number means that x has always be less than x squared? Actually, no. That is not true in all cases. There is a bunch of numbers that are never less than their squares, and those are positive decimals. Say, for example, if x equals 1/2, then x squared would be 1/4. And you know, 1/2 is not less than 1/4. So we can consider two cases of use here for different values of x squared, and y as evidence of what we have analyzed here. Let's say, for example, that under the true condition that x squared is always less than y, okay, we say, okay, how about x squared being 4 and y being 5? Okay, x must be 2. So, in both cases, we can verify that x less than y is true because 2 is less than 5. But what about if x squared were 1/4 and y were 1/3? It is true that 1/4 is always less than 1/3. This is our premise, right? As it is stated above. But what about the value of x? If x squared is 1/4, then x would be 1/2. So is 1/2 less than 1/3? No. So we say that x less than y is not true, it's false. We so verify that this affirmation, inequality number 2, is not always true. So what about the third one? The third one can be simplified in terms of multiplicating both sides of the inequality by the same factor y in order to make linear the inequality. So we multiply by y both sides and we get this. Why? Because y is a positive factor as it is stated above in our premise. But this resulting inequality actually coincides with this one. So it must always be true. Therefore, after we finish our analysis, the statement that is always true provided the above condition, 0 is less than x squared and x squared is less than y, is just the third inequality. So this is the correct answer choice. Statements 1 and 2 have two inequalities that are true only sometimes, okay? Not in all cases.